Hello, ladies and gentlemen. So this is going to be the last lecture of the week. It's going to be lecture 6. And we're going to do one thing in this lecture, one problem, which is number 15 in the exercises section of chapter 2. It's about the computation of the probability of various poker hands. So let me get started. Let me share the screen, the whiteboard. Okay, so this is going to be lecture 6. And I'm going to do problem number 15, which is about poker hands. And this is going to be a short lecture. So let's recall the number of 5-card poker hands is 52, choose 5, which is exactly 2,598,960. Okay. So what the problem is it lists various poker hands and asks us to compute how many there are. So in part A, we let E be the event that the hand is a flush. Now, what's a flush? Remember that there are 4 suits, spades, hearts, diamonds, and clubs in a poker, in any standard deck of cards. So there are 4 suits. Each suit has 13 cards consisting of ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And that's all there is. So now a flush are any 5 cards of the same suit. So 5 cards of the same suit. So 5 hearts or 5 clubs, etc. So the question is how many, what's the probability of getting a flush? Well, this is any 5-card hand is equally likely to any other 5-card hand. I mean, in terms of just being dealt cards, right? So we have to compute the number of E divided, this is S is, the sample space is all 5-card hands, and we know that that's given by 52, choose 5. So we have to compute the number of flushes. And how do we do that? Well, how are we going to do that? The first thing to note is that to choose a flush, you have to choose a suit, and there are 4 suits. So there are 4 choose 1 suits. So the number of suits, we're selecting a suit. Either we're selecting a heart, or a club, or a diamond, or a spades. And within that suit, we have to choose five cards out of the 13 in the suit. So there are 13 choose 5 possibilities there. And that is actually the answer for the size of E. And now to get the probability of E, we have to take this number 4 choose 1 times 13 choose 5 and divide it by 52 choose 5. And that will give us some number which is approximately very close to 0.0022 or 0019, in fact, if we want to get very more specific. Okay, so that's the first part. Let's go to part B of the problem. So E then in this case is 1 pair. 1 pair. What's the probability of getting 1 pair? So we have to compute how many ways there are to make a pair. So that's the cardinality of the event of making a pair. So how do we make a pair? Well, we have to choose the denomination of the card, the number of the card, if you will, where the pair is to be made. So that means we have to choose the value of the pair. So is it a 2? Are we getting a pair of 2s? Or are we getting a pair of 5s? We have to choose some card out of the 13 we're going to make the pair. Now in that numbered card, in that denomination of card, we have to choose 2 cards. So there are 4 cards in that denomination, and we have to choose 2 of those cards. So that gives me all possible ways of building a pair when being dealt with 2 cards. Now we have 3 other cards to take which are not equal to these given cards. So now we have to choose those 3 cards in the following way. We want to choose We want to choose the remaining 3 cards have to be chosen from the other denominations, and those denominations cannot be equal. We cannot, for example, choose another pair because that would be bad. So we have to choose, there are 12 denominations left, and we have to choose 3 of them for the 3 remaining cards. And where do we get those cards from? Well, each card has to be chosen from a suit. So the first one of the cards has to be one of 4 choices. The next card has to be one of 4 choices, and the last card has to be one of 4 choices. So if you compute what this is, you'll get 123,552 is the answer. So the probability of E is the size of E over the size of S, the cardinality of E over the cardinality of S. And we know that that's 123,552 over 52 choose 5. And that's about 0.0. That should be, oops, did I get that right? Oops, I copied the wrong part of my notes. I have to go back, sorry, I did the arithmetic incorrectly. So here's the corrected arithmetic. Here we go. This is not what I said it was. It is actually 1,098,240 possibilities. How did I compute? How does this computed? You go to either your calculator or you go to an online combinations calculator, and it can be calculated that way. Okay, so the numerator here is not what I said it was. It was 1 million. It is actually 1,098,240. And this should give you a value of 0.4226. In other words, about 42% of the time you'll be dealt a pair. So 42% of the time the dealer will deal you a pair. That's pretty high, actually. Okay, so there we go with that. I'm going to save the okay, so let's go to part C. I think this is actually the next one. No, this is not too bad. So part C goes like this. Let me clear the screen. Okay, so part C is the event of making 2 pairs. So for example, we could get 2 5s and 2 jacks. How do we do that? Well, we want to figure out the number of ways to make 2 pairs. In order to make 2 different pairs, we have to choose 2 different suits from the 2 different denominations, I should say, of cards. When I say denomination, I mean a 5 or a 7 or an ace or a jack. That's a denomination. So we have to choose 2 denominations to make the 2 different pairs. Now, in the first pair you're going to make, you're going to choose 2 cards out of the 4 cards that appear in that denomination, and likewise for the other pair you're making, you have to choose that. So that's going to be multiplied. Now that takes care of 4 of the cards that are being dealt to you. You have a 5th card, and that 5th card cannot come out of those 2 2 cards you've chosen from the 13 denominations. So you have to choose a different denomination, and there are only 11 denominations left. So there are only 11 denominations left. And in that denomination, you have to choose which card you're taking. So there are 4 choices of that. Okay, so this product is something I wrote before incorrectly in the other problem. It's 123,552. So the probability of E is the size of E over the size of S. And you can compute it. It's going to be 123,552 over 52 choose 5, and that's going to be about 0.04754. So that's only about 5% of the time. 5%, about 5% of the time, you'll be dealt 2 pairs. That's not very common. Let's go to 3 of a kind. So if that's our event, E is 3 of a kind, how many ways are there to make 3 of a kind? Well, you have to first figure out which denomination you're choosing your card from to make the 3 of a kind. So there are 13 denominations. And in that denomination, there are 4 cards. We have to choose 3 of them. And now we've taken up 3 cards in our hand, and now there are 2 cards left that we have to select. And they can't be equal to the cards in the 3 of a kind of the denomination we've already chosen. Okay, so what do? Well, we have to choose 2 cards from the remaining denominations, right, which are 12, because we've already used up a denomination. And each of the cards that we choose, there are 4 choices from the 4 suits. And so this is for each of the cards. And now this product is given by 54,912. And so the probability of E in this case is 54,912 divided by 52, choose 5. And that's going to be, believe it or not, it's going to be 0.02113. So that's about 2% of the time. In other words, if you deal the cards 100 times, you would expect it's likely to get 3 of a kind in 2 of the hands that are dealt. Okay, so let's go to E, which will be 4 of a kind. Okay, so how does that work? Well, we have to choose, in this case, E is 4 of a kind. And we have to choose the denomination to make the 4 of a kind. So that's 13, choose 1. Now we have to select all 4 cards in that denomination. That's 4, choose 4, which is, of course, just one way to do it. And now we have 4 cards that have been eaten up. And we still have to be dealt 1 more card that's not equal to any of the cards that were dealt. 4 cards were dealt out of 52, so there are 48 cards left. And we have to choose one of those 48 cards. That's the remaining card. And there are 624 possibilities there. So the probability of E is the size of E over 50, choose 5. So 624 over 52, choose 5. Oops. And that turns out to be 0.00024, which is about 0.2% of the time. Or is it? No, it's 0.02% of the time. Okay, I'm going to do one more problem that's not listed in the text. It's an easy one. I just thought I would show you how rare it is. There's something called a royal flush. So let me explain that. So I'm going to clear the screen. So so let's call this F. It's not in the problem, but a royal flush. So a royal flush is a flush that's made up of ace, king, queen, jack, 10. So in other words, it's a suit where you get all of these cards. Now, how many ways are there to do that? Well, there are only 4 possible royal flushes. So the size of E is 4, right? You can either get an ace of clubs, king of clubs, queen of clubs, jack of clubs, 10 of clubs, or the same thing in hearts, or the same thing in diamonds, or the same thing in spades. So the probability of E is 4 over 52, choose 5, which is a very small number. It's 1.539 times 10 to the minus 6. It's extremely rare. Almost never happens. It happens, but it's very rare. So that is all for today. Take care. This is the end of the week.